military sign out. Put in the So in 625 line monochrome system, so for a successful interlaced scanning, the entire 625 lines of each frame or picture divided into two halves. So 312, 312.5, and each set is scanned separately. Each set is scanned separately. To cover entire picture area. So what is the advantage? What is the advantage with this interlaced scan is nothing but entire picture should be covered. Entire picture should be covered such that the perceiving of vision are be very good in the sense for a viewing point of view. So that is the main importance of why do we perform interlaced scan. So to achieve this one, we require some hardware maintenance. We require some hardware mechanism in the raster screen circuits. That mechanism here termed as horizontal sweep oscillator. So that is the block inbuilt in the particular device, so called horizontal sweep oscillator. So this horizontal sweep oscillator works with some frequency. So how to get the frequency? Simply, so the number of scan lines multiplied by period. So that equal to your 50. So what is the 50 drawn here already in the previous lecture? We found the 50. Clear? These are our 50 vertical scans. So to get the frequency, simple multiplied this 412. Simple multiplied to achieve this simple multiplied number of lines 312.5 multiplied by vertical scans 50. So we are getting 15625 Hz. So that is equal to your frequency 15625 Hz. So this is the frequency where you are able to achieve the value. So that is the 15625. So this 15625 is required to scan this number of lines per frame. Sir, no? Yeah, very good. These number of lines per frame can be available dividing this value with the number of frames. So therefore 15625 here divided by number of frames. So you are getting 625 lines system but your vertical sweep circuit run at a frequency 50 instead of 25. Clear? So that is instead of 25, our vertical frequency is able to calculate the value such that the information is scanned with this 25. Good. So shall we move next slide? Yeah, good. So since the beam is now deflected from top to bottom, clear? If the beam is deflecting from top to bottom, so half of the 50% of time required to end, 50% of time 50% of time required to operate this horizontal oscillator. So can anyone say the frequency for horizontal oscillator? Yeah, that frequency for oscillations are yesterday in previous class we found that there is a 15625. Clear? So 15,625 Hz frequency required to run our circuitry, that is horizontal circuitry. So to provide this one, only just 15% required. So 625 by 2, 625 by 2, you are getting 312.5. So get scanned during each vertical sweep. So for that type of beam, since the field lines, half line and the second half field commence at the middle, so of the line, top of the target plate and screen, so the beam is able to scan remaining 312 lines during this forward jet. So therefore interlaced scan, by using this interlaced scan, there is a way to eliminate the particular frequency in very good order. So what is our conclusion? What is our conclusion? It may be noted that frame reception rate of 25 was chosen to make the field frequency equal to power line frequency of 50 Hz. Yeah, very good. So this helps to reduce the undesired effects of human eye due to pickup from a various factor, because then such efficient in picture stay instead of during up and down. The American TV system were adopted because of the frequency 60 Hz. So this brings the total number of lines. This brings total number of lines that are scanned per second 525 by 2 into 60. So you are able to catch a 625 line system. So next we are going to move to know the what are the so next topic goes to scanning periods. Clear? So what are the scanning periods? So here scanning periods are nothing but the wave shapes of both horizontal and vertical circuits are that we are going to watch in the next slide. So that for each period, so as shown, there are retrace times involved in both the horizontal and vertical due to the physical limitations of the practical scanning system and are not utilized for transmitting and receiving that video signal. So with interlaced scan, what is our thing? With interlaced scan, what is our conclusion equal to these horizontal and vertical lines? These horizontal and vertical lines are very important to retrieve this shapes of the scenes. So horizontal and vertical requires to get the perfect shapes. Govinda. Yes, sir. So as shown here, so as shown there, as shown here, the retrace time involved in both horizontal and vertical due to the physical limitations of practical. So one can say what is the normal duration, what is the minimum duration for this horizontal lines, what is the minimum duration for this type of horizontal duration. Can anyone guess how to maintaining that? Can anyone guess how to maintaining this one? How to maintain this? So the normal duration. So the normal duration. The normal duration of these horizontal lines as shown here. So the main limitations. So the main limitations for this one. So that is equal to your 52 microseconds. The remaining equal to 12 microsecond. That is the line blanking period. So the nominal duration for this horizontal line, how to calculate that normal duration equal to 106. What is the 106 equal to? That is the previous lines that you are obtained. So divided by the 115,625. So 106 divided by 15,625. మమ్మీ పెట్టద్దండి ఇక్కడ So there the beam returns. During the short interval to the extreme left side of the frame that should be transmitted during the next cycle. So in this way, you are able to estimate the period of the scanning task. Clear? So this period of scanning tasks are estimated to provide the field frequency. So similarly, with this field frequency set to 50 Hz, so the nominal duration of this vertical trace is approximately how to calculate 1 divided by frequency. So 1 by 50, 20 millisecond. So out of this period 20 millisecond, what is our estimation goes? Some out of 20, 18 spent from forward and 1.280 spent backward. So that is the conclusion drawn here. Out of this period of 20 millisecond, 18.720 spent in bringing the beam from top to bottom, and 1.280 is taken by the beam to return back to the top to commence the next cycle. Clear? So this is the way how to guess the scanning period for our interlaced scan. So therefore, sweep oscillators are plays very important role to take this interlaced scanning in future. So therefore, vertical and horizontal sweep oscillators, vertical and horizontal sweep oscillators are continuously to achieve the fast sequence of this vertical scan lines. Therefore, 20 horizontal lines get traced during each vertical retrace of the particular interval. So that's why in horizontal and vertical sweep oscillators, they are able to operate the sequence of this interlaced scan with about 20 horizontal lines. So therefore, they get to trace during each vertical retrace of the interval. So therefore, for our estimation, 40 scan lines, 40 scan lines are lost per frame. Clear? How you can justify this line? How you can justify this line is nothing but out of 20, 18.720 for occupying the top to bottom, 1.280 occupied for vertical retrace. Therefore, 40 scan lines are lost per frame, but their blanking lines are during this long retrace interval of these two fields. So with this knowledge, we have required number of scan lines along with factor. So that is active number of lines. So active number of lines for scanning the picture details is our total minus this scan line. So 625 minus 40, you are getting 585 instead of 625. So this interlaced scan is able to make their effectiveness to hold the entire operation from 625 to 585. So this is the horizontal and vertical deflection mechanism shown in the waveform. So on x-axis time period taken, on y-axis their deflection current taken in both horizontal and vertical directions. So I think you are all watching the waveform on your screens. So what is the observation from these waveforms? First, for horizontal deflection current, trace period require total 64 microseconds. So out of 64 microsecond, just place majority 52 microsecond for what trace period. The rest of 12 microsecond is adapted to for your retrace period. So this trace period and retrace periods are very popularly utilized for your trace means. So that is 52 microseconds are required. So 52 microseconds are required to implement this task. So therefore, to activate this trace and retrace, just you can require 52 and 12 microseconds. So therefore, horizontal deflection required to maintain total time period that equal to 64. So that equal to your 64. So during this period, so what is the our discussion? What is our discussion equal to your trace and retrace period? Your trace and retrace period is able to catch the meaningful value. So for horizontal deviation, so you require to attach. So to achieve this one, there is a method. There is a clarification required on this one. So next one, the complete geometry. Okay, the complete geometry of standard interlaced scanning patterns are illustrated in the previous picture. So note that the lines are numbered in the sequence in which these are actually scanned, and for your 20 or 20 lines. So you are to maintain first vertical retrace. So therefore your 292 systems are able to catch the signal. So these are the important mechanisms that so note that the lines are numbered sequencing. So therefore your so here number of lines which are transmitted. So note that the lines that are numbered here, which are we maintaining that the beam starts here. What is this here? So the beam starts at the end. Therefore, the scanning sequences are required. So at the end of this trace, the beam is then retraced rapidly. So therefore, to the left side. Therefore, what happens on this one? You are requiring the corresponding horizontal beam deflections. Therefore, at the end of this trace, the beam then retraces rapidly to the left side of the frame, and note that horizontal lines slope downwards in the particular direction of the scan because the vertical deflecting current simultaneously produces a vertical scan motion. So the slope of this horizontal trace, from left to right is greater than during the retrace from right to left. So the reason is that the faster the retrace does not allow the beam so much time to deflect it vertically. So therefore that means you are able to maintain the scan periods in proper way. You are able to maintain scan periods in the proper way. Therefore, your limitations should be encounterable and to get the maximum thing. With this knowledge, let we recall the scan periods. So after line 1, what is happens? That is after line 1, the beam is at left side rapidly and scanning the maintaining. So however, the mentioning earlier, it is convenient to number of the lines. So they are scanned. So the next scanning line, skipping one line. So the number 2 and more are required for that particular 3. So this process continues till the least line gets scanned half and that vertical motion reaches the bottom of the raster or frame. So after this long time, after that line 1, so that beam, this process continues till that last line gets scanned half when the vertical motion reaches the bottom of the raster. So this is the way how this is scan lines. This is the way how these scan lines are be continuously called after the long time. The left side is, however, that maintain the vertical motion reaches the bottom of the raster or frame. So that is the skipping lines. So now we are moving towards scanning periods to scanning sequence. That so as explained earlier, skipping lines of this accomplished doubling the vertical frequency from the frame or picture reception rate to 25 to the field frequency is about 50 Hz. So with the field frequency of 50 Hz, the height of the raster is set to 95. To 95. Therefore, the bottom was you are able to call them as in the way. So here you are mentioning some pictures, that is the scanning sequence. So what in the picture A, in the figure A, we have here in the figure A, you have here first vertical trace. So what is the first vertical trace? In total 313 lines. In total 313. Consider total frames. Total frames are 625. Total frames are 625. The 625 lines are divided into field 1, field 2. In field 1, total lines are 312.5. In field 2, total lines are 312.5. So again, the 312.5 lines divided into two parts. That is for 1 2 half and rest of this one. Clear? That is the majority of 20 lines system. So we are estimating the 20 lines system. So for 20 lines are helpful to maintain scanning sequence in the proper order. So out of this 312.5, 20 lines are reserved for inactive lines for first vertical light cycle. Similarly, for second field, 20 lines are kept for inactive lines during the second vertical trace. So in the first field, during the first vertical trace, 292.5 lines are left for this one. 292.5 lines are left for the first trace, and where 20 lines are left for the second trace. So 1 to 292.5, 1 to 292.5, the first vertical trace starts where your beam can reaches to maximum value. And the rest of 20 lines are tagged. The rest of 20 lines are kept for your inactive lines. Clear? The rest of lines are kept for inactive lines due to the various retrace version. So therefore trace and retrace periods are done. Therefore the perfect synchronization is made at the end of the line. So therefore you are able to view the picture with very good comfortable. So for the second field, so you are be in the way to catch the second vertical trace. That is the next 312.5 to 605. Just you add 312.5 to 312.5 to 292.5. So you are able to get 605. Clear? 605. So here 605 lines are kept. 605 lines are kept for here for maintaining the. So here what is the answer here? 292.5. Clear? Plus you just add 20, so you are getting what? 312.5. Similarly, for 312.5 you can add just 2 9 on the closed door. 292.5. Therefore you are able to get what 292.5. You are able to get 605. So 605 plus 20, so you are able to get what is the answer here? 625. So this is the way how you maintain the particular scanning sequence. So therefore your iterations are helpful. Your iterations are helpful to retrieve this information, to maintain this information for your knowledge of sequence. That will be explained in that literature. So skipping lines are accomplished by doubling the vertical scan frequency from the frame, the picture resolution. So therefore 25 to the field frequency of 50 Hz. So with this field frequency of 50 Hz, the height of the raster is set to scan total to 92.5 lines get scanned whether the beam travels from top to bottom. Clear? So that is the point he explained here. Now the retrace array starts and takes a period equal to 20 horizontal lines, and the periods are maintained to figure number C. So these 20 lines are known as inactive lines. Scanning beam is cut off during the particular period. In the second field starts at the middle of the raster. The first line scanned is second half of the line 313. So the scanning period of field starting at the middle of the raster automatically enables the beam to scan the alternative lines left and right. So therefore your broader view of the unscanned during the first field. So what is the importance? What is the importance of these lines? What is the importance of these lines in that ability? So the vertical scanning motion otherwise is exactly the same that is the previous page. Clear? So as a result, total lines get scanned. The beam reaches to the bottom of the frame when it is has completed using your line number of 605. So therefore inactive periods, that is inactive vertical retrace again begins and brings this beam back to the top at the point A. So therefore the period which is equals to 20 blankened horizontal lines. So back at a point P, the scanning beam has just completed two fields or one frame and is ready to start a third field covering the same area. So therefore number of lines are scanned during the first field. So this process is continued at the first rate of 50 times a second, which is not only creates the illusion of the continuity, but also to solve the problem where your flicker is satisfactorily available.